Hi everyone. In this video, we're going to talk about loops. We'll see what a loop is and how it allows us to repeat instructions in our programs. We'll look at a couple different looping keywords and what the difference is between them, and then discuss when it is that we use a loop when we're designing our programs. So this is our last big building block. Once we've got this, you have pretty much everything you need to write any kind of program you'd ever want. So it's a really exciting topic, and let's get started. So as I mentioned before, a loop is the instruction that we give a computer when we want it to repeat some block of instructions more than once. So we could just copy paste those instructions, 3 times in a row, and they would run 3 times. But doing this would cause a couple problems. First, if you wanted to change anything, you'd have to go and change it 3 times. We had talked about a similar sort of problem back when we first introduced functions, where, you've copy pasted something somewhere else, and now you have to remember to change it in both places if you find a bug or you need a new behavior. And loops are really designed with this same philosophy in mind, that we as the programmers don't want to repeat ourselves ever. So if something has to happen more than once in the program, we want to write it one time and then say, do this 3 times in a row. So what that might lead you to conclude is, why don't we just use functions for this? So functions would reduce the amount that we're repeating instead of writing all of our instructions and copy pasting the entire block of instructions multiple times. Instead, we would just write the function name however many times, but we would still need to copy paste and tweak things if we changed how often it runs or under what conditions it runs. There are actually ways to do looping with functions, advanced techniques you'll cover later in your programming career, but even they are not the best fit when we just want a really simple block of repetition. These loop instructions that we're covering in this video are going to be your simplest way to say, hey, Python, I want you to do this thing 2, 3, 4, 10 times while only needing to write it just once. So there are 2 different forms of loop that we'll look at. The first of these is the while loop. And the while loop is very, very similar to the if statements that we've already looked at. If you remember, the form of our if statement was if some condition, then here are some instructions to follow, that block of code that we want to do. And when this instruction was reached in our program, Python stops and evaluates whatever this Boolean expression is. It could have ands and ors and nots in there. It could call functions that return true or false. When it evaluates that down to a final answer, if it's true, it would run this. If it was false, it would skip it. And so far, everything we've said is exactly the same for a while loop. Except that instead of the word if, we put the word while so that Python can tell the difference. But our program is running, we get here to our while loop, and it sees while Boolean condition. And now it's going to branch off in 2 directions. When the Boolean condition is true, it will follow the instructions. When the Boolean condition is false, it'll skip the instructions. And that's exactly what an if statement does. But with our while loop, there is one crucially important difference. And that is when the condition is met in a while loop, when we get to the bottom of this instruction block, we loop back up to the condition and test it again. So this is where that name loop comes from, because it's like if our program execution, the instructions we follow, were a piece of thread running through the program. It's almost like we've looped it, bunched it up here made multiple passes in a spiral before eventually we hopefully continue down to the end of our program. It's literally like we took this little arrow at the bottom of our if statement and bent it back up towards the top when the condition is met. And this is a very powerful, very versatile instruction. This Boolean condition that we're checking for, it could be user input. Say we need them to enter their age and we check if their age is a valid date, then there's something we want to do. If not, we want them to try again. We could say while it is not a valid age, the instructions for entering an age, and then we test, is it a valid age yet? If not, give it to me again, give it to me again. And when eventually they give us something valid, then that expression turns to false because we said when it's not a valid age, and then the program can continue. Same thing, it could be a user guessing a number, a user picking a menu choice from among a series of options. As long as you can express when it is that something should repeat and when it is that you should move on, you can put that in the Boolean condition of a while loop, and then your program will keep doing that same part again and again. This does have one important consideration, something new programmers will trip themselves up on all the time, which is when you are writing a while loop, your Boolean condition better use some variable in there. There better be some changing component of this. It might be a function call that is doing this computation, but something better look at the current state of the program, and somewhere in these instructions inside your loop, something better change that state. If we're testing that the user's age is valid, we better change their age variable inside this loop. Because if not, if we went in the first time and nothing changed, we're going to go in the second time and the third and the 1,000th and the 100,000,000th time. If nothing is actually changing a variable in our Boolean condition, we can never leave the loop. That's what's called an infinite loop, and it is probably the #1 source of introductory computer science headaches for students. They get to loops, they've learned this new tool, and suddenly it's like their programs never stop anymore, because if you're not even pausing and waiting for user input, it'll just look like the program has frozen. In fact, a lot of the times when a program does freeze, when you see it go gray and you get the click to close dialog, that's often because some loop has gone out to lunch and is now repeating itself forever and ever and ever. So that is our one consideration for while loops, is make sure something in this condition is changing so that we can eventually break out of the loop and continue on. So that was our first type of loop, while loops. The second type of loop, for loops, is actually just a convenience feature for writing a very common type of loop more quickly. So for loops are the type of loop we use when we want to do repetition over each item in a group of things. So that's a kind of vague description. It's a little more solid if we look at a common example. And that is saying, I want to loop over each number in a group of numbers. Say I have the numbers 1 to 10, I have 10 students in my class, or I have 10 envelopes I have to stamp and send in the mail, whatever it is. With a for loop, we can write code that really succinctly will repeat that 10 times to do it, or however many we need. And the way that we do that is by writing a slightly fancier condition line when we're entering the loop. For a for loop, the form this is going to take is for some iterating variable in a range with an x, a y, and a z. And that x, y, and z, this first component, the first argument to this range function, is going to be what number do we start at? The second one, the y here, is going to represent when do we end? And the z is going to be how much do we step up by each iteration of the loop? So if I said for next number in range 1, 10, 1, I'd be saying start at 1, go up to, but not including 10, and go up by 1 each time. So if I did that, this loop would run 9 times. It would run when next number equals 1, and then when next number equals 2, and then 3, 4, 5, 6, 7, 8, and 9. And then it would automatically break out of the loop. There would be no worrying about us manually adjusting this next number variable. And the neat thing is, in my loop body, in the block of instructions, I can use that variable like any other variable, and each pass through the loop, it'll get the next value from our group. So this for loop is really convenient when we can very explicitly state how many times we want something to happen, or we've got a collection like we'll learn about in our next video, and we want to make sure something happens for each item in that collection. Otherwise, the loop actually isn't that different from the one that we looked at before, and in fact, every single for loop that ever existed, that ever will exist, you can write it as a while loop, because all this is saying is I've got some variable that starts at this value x. I'm checking that I am not yet at the value y, and each time I am changing by the value in z. What that means is I could actually declare that variable myself right before my loop begins, say next equals x, and then I could use my next thing, that y, as my Boolean condition, saying while my next is less than the y, keep repeating. That's the thing that's doing the test in this range, is that middle number. And then in my block of instructions, do all of the instructions I had before exactly the same, but at the very end, put next equals whatever next was plus this z, because that's all that z is saying, is how much to step up by each time. And if I make those little changes, I've now converted my for loop into a perfectly valid while loop that will still run. So if your brain only has enough room for one kind of looping expression, I'd suggest you stick with a while loop, because a while loop can do for loop things as long as you recognize this pattern of how to express them. For loops are still very convenient and very worth knowing, but it is interesting to see how we can build even our more complex Python instructions from other Python instructions we've already learned. So that is our for loop. And those are the two different types of loops that we've got in Python. As far as when we should be using these instructions, anytime you find yourself writing the same thing more than once back to back, even if it's with slight changes, you should see if there is some way that you could express a Boolean condition that describes when the looping should end or continue. That is the one other thing that does trip people up, is if statements. You tend to think about them in terms of when do I follow the code. Loops, you tend to think about them in terms of when do I leave the looping. So you might have to be careful with your nots if you are reversing what you originally conceptualized a loop as. Your Boolean condition remember, it's going to be what makes the loop happen again, but the relevant thing is thinking about when do we leave. So that is when we use loops, is whenever we've got something that's repeating more than once. And then the question of while loop versus for loop comes down largely to, do you know exactly how many times the loop is going to run? If you know how many times the loop should run, or you know you've got a variable that knows how many times the loop should run, then for loop is probably going to be the most ergonomic. It's going to be the prettiest looking loop that you could use. If you don't know, because maybe it's input that's coming from a user that we have to validate, maybe it is something coming from a file or from the internet, or you're waiting for something to happen and you don't know when it will, that's when you're going to reach for a while loop. It is a more general purpose tool for any complex condition we could think of. There is one special instance of a loop that we're unlikely to write in an introductory programming course, but that is very, very common, that sort of breaks our rules of loops. And it is the one other time you'll use a loop in programs. And that is that programs that run forever, or at least until they're closed, often the very first instruction in the program is a purposeful infinite loop. It's a program that intentionally loops forever. It might literally be while true, and then all of your instructions. And the reason that this gets used that way is that it makes sure, as a user navigates through the program, as we're displaying something, if it's a visual program, users are always returned back to the main scene or the main menu after they've performed a task. That the only way to actually end the program is to tell the program to close itself. When you've got a situation like that, an infinitely running program, that will often also be expressed with a loop, because we want the whole program to repeat forever. So that's a slightly different usage of loops, but it shows you just how flexible this instruction is. Like I mentioned at the start of this video, this is really the last building block you need if you've got loops, if statements, functions, and variables. You can express any program you can think of. You have all of the tools in your belt to do any type of programming you can imagine, as long as you can find the correct functions to call. Everything after this is just learning patterns and tripping points and other useful features unique to different languages that make your life a little easier, but don't actually change what you can do in programming. You now know it all. So from here, we will be looking at lists, which are a very convenient tool for holding a whole bunch of information in one single variable. That's going to be our next video, so look forward to that. And until then, I'll catch you all in the next one.